Okay, so we're on page 106, so the last 4 pages of our notes. And this is dealing with solving logarithmic equations. So 6.5 was solving exponential equations, and now we are looking at log equations, which very similar process, but we are just going from a different approach. So before, when we were solving exponential equations, I kept telling you, you can either put it in log form, or you can take the log of both sides. Well, now we're starting with log. And so when you are dealing with logs and you're trying to shake things up a bit, usually what happens is you would be changing it to exponential form. For instance, on this first one here, I have the log of x plus 4 equals 4. Remember that if you don't see a base written in, we can assume it's a 10 right there. So what I'm going to do is I'm actually going to put this in exponential form by making that 10 big, switching a 4 and the x plus 4. And then I would have to subtract 4 from both sides. So x is going to be 10 to the 4th power minus 4. 10 to the 4th power is 10,000. And 10,000 minus 4 is 9,996. And that's going to be the answer for x. I want you to take a moment, try the same thing, the same process on the second example. And so pause the video and come back in just a moment. Okay, so I'm going to raise 10 to the power of 2, and that's equal to x plus 20. I just changed that to exponential form. I would have to subtract 20 from both sides, so I have 10 squared minus 20 equals x. 10 squared is 100, and 100 minus 20 is 80. Let's look at the next page. Real life scenarios when you're dealing with log equations is using logs as a way to measure earthquakes. So the size of an earthquake is most often measured by its magnitude. In 1935, Charles Richter defined the magnitude of an earthquake to be this simple formula here. Magnitude equals log of I divided by S. I is standing for intensity of an earthquake. It's measured using centimeters. And it's read by a seismograph, which is a tool that it looks kind of like a heartbeat monitor at the hospital, except the only time the heart beats is when tectonic plates are crashing into each other and making shakes and stuff like that. There actually was a seismograph in the school that I went to high school in Carthage. And anytime we have an earthquake up here, I actually call my friend, who's a science teacher there, and ask him what the seismograph looks like. And sometimes he'll send me a picture, which is kind of cool. Back to this, though. I is intensity measured in centimeters, and S is the intensity of a standard quake. So, which in this case, we're going to use 10 to the power of negative 4 for S. So we're going to use that in place for S. Okay, so if the intensity of an earthquake was 40,000 centimeters, what would its magnitude be? So if magnitude equals the log, intensity on top is 40,000. And then, like I said before, we're going to put the standard earthquake amplitude at the bottom. So 10 to the power of negative 4 goes on bottom. And basically all I'm doing is putting this into the calculator and coming up with an answer. So let's do that. And there it is. On the Richter scale, the magnitude would be 8.6. Hold on a minute here. There we go. 8.6. And you get kind of instinct for whether or not 8.6 would be a strong earthquake. And yes, it would be a very strong earthquake. So really interesting. What is the intensity of an earthquake that has a magnitude of 6.5? So if we're using magnitude equals a log of I over S, I would be plugging 6.5 in for M. And we're looking for I. Our S is that 10 to the negative 4. So now we have to solve this, and we have a variable buried in a log. So I'm going to have to change this to exponential form, which means that I would make the 10 big, and I would switch out 6.5 with I over 10 to the power of negative 4. And if I wanted to solve this for I would multiply both sides by 10 to the power of negative 4. Now, I could put this in my calculator, or I can remember that if I'm multiplying powers that have the same base, I would add the exponents. In this case, my exponent would be 2.5, 6 plus negative 4. And then that's what I'm going to put in my calculator, is 10 to the power of 10 to the power of 2.5. So give me 1 second. Okay, so I've gone ahead and put the calculator thing on here, and it's all crooked and whatever. 316.23 centimeters would be the intensity of this earthquake. Let's go to the next page. What is the intensity of an earthquake with a magnitude of 8? I'm going to let you pause the video and do this on your own, and then come back and see if you got what I got. So go ahead and pause now. Okay, so if I have the m equals log of I over s, and m is 8, and I need to fix my handwriting. We're looking for I. We're going to change this to log form, which would be 10 raised to the power of 8 equals the I over 10 to the negative 4, which I'm going to multiply both sides by that. Remember that if I were to multiply powers that have the same base, I add the exponents, so this would be 10 to the 4th power. And 10 to the 4th power is 10,000. So we're going to say 10,000 centimeters. Solve the following log equations and round your answers to 3 decimal places. Okay, so fun times, let me tell you. Some of these can be solved using properties and other things that you know about logs, and some of them can be solved with common sense. For instance, if I look at A, they're asking me what number I can plug into X to make the left-hand side equal the right-hand side. If you plug in 5 for X, then you have the log of 5 equals the log of 5. So, okay, that's not too bad, right? Let's look at B. The natural log of t equals 3. If I want to solve this, I am going to have to write this in an exponential form. Remember that there is a base e here, so if I write this in exponential form, the e becomes big, the 3 and the t switch spots. And just remember, e is just a number. So if I put e to the 3rd power in the calculator, it's just going to spit out a number to me. So give me 1 sec. There it is, folks. Once you put this in the calculator, it's going to tell you that t is 20.086. I think it said 3 decimal places. Okay. Then let's look at C. C, again, you want to solve for x. I have to isolate my log, so I'm going to subtract 7 from both sides. Ugh, what am I doing? Log of 2x equals 5. And then I'm going to change this to exponential form. So my base becomes big. My 5 and my 2x switch spots. Remember that I want to divide both sides by 2 if I have x here. 10 to the 5th power is 100,000. And 100,000 divided by 2 is 50,000. Okay, let's go to the next page. Solve the following log equations. A is pretty simple. Your log's isolated, so we're just going to change that to exponential form. 10 to the power of 3.5 equals x. If I put x in the calculator, 10 raised to the power of 3.5, it's going to give me 3,162.28. Okay, let's look at B. The log of x plus 12 equals the log of 20. Again, common sense approach. If I want this to be equal to the log of 20, what can I plug into x to make what's inside this parentheses be 20? Hopefully you're saying, well, if x is 8, then that would make the log of 20 equal to the log of 20. So that's the thing. Okay, for C, I'm going to subtract 8 from both sides and isolate my natural log. And then I'm going to write this log in exponential form. So your natural log, base E gets big, negative 5 comes here, 5x goes to the other side, and then I'm going to divide both sides by 5. In my calculator, I have e to the negative 5 over 5, which is, here it is up here, e to the negative 5 over 5 is 0.00135. Very small number. Okay, solve the following log equations and round your answers to 3 decimal places. Please remember, I'm looking at this and this just looks like something expanded. What if I wrote this as a single log? Remember that when you are adding, that means that inside your parentheses it's multiplying, right? So this is log base 6 of 2x squared equals 2. And I'm going to write this in exponential form. 6 to the second power equals 2x squared. So I made my 6 big and switched out the 2 and the 2x squared. I'm going to divide by 2. So that gives me 3 equals x squared. And then I'm going to take the square root of both sides. And remember, if I take the square root, I have to put a minus sign here. So x is positive square root of 3 and negative square root of 3. 2 answers. Go ahead and do B. Come back after and see if we got the same answer. Okay, for B, I'm going to have the log of 2x times x minus 4 equals 1. And that is the log of 2x squared minus 8x. Now, I want to write this in exponential form. So I'm going to have 10 raised to the power of 1 equals 2x squared minus 8x. And I'm going to subtract 10 from both sides, which is going to end up giving me this. What can I do with this? I can solve this by factoring it. I can factor a 2 out. I'm actually going to, for a moment, just erase this. 2 comes out, x squared minus 4x minus 5. 2 numbers that I can multiply to get negative 5, but add to get negative 4. That would be negative 5 and positive 1. So this gives me 2 solutions. One of those solutions is 5, and one of those solutions is negative 1. I will not give you anything like this on your homework where you have to factor and solve, because we didn't really go through quadratics very much. But I just want you to know that that's a possibility. That's something that could happen. It's just not going to happen to you. Okay. Erasing this stuff. Let's look at C and D. C, we are looking at writing this as a single log base 2 of 3x squared over x equals 5. I can actually simplify inside those parentheses and just make that log base 2 of 3x equals 5, because one of these x's cancels with one of these. And then I can write this in exponential form. 2 to the 5th power equals 3x. Divide both sides by 3. In my calculator, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So my answer is going to be 32 divided by 3. I'm leaving it that way. Okay. This last question, again, is going to result in you having a quadratic, but we're still going to do it. Log base 2. I'm writing this as a single. So x plus 5 times x plus 4 equals 1. Log base 2 of x squared plus 9x plus 20 equals 1. Then I'm putting this in exponential form, which is 2 to the first power equals x squared plus 9x plus 20. I'm subtracting 2 from both sides. So now I have x squared plus 9x plus 18 equals 0. Is there two numbers you can multiply to get 18 and add to get 9? Yes. One of them is 3 and the other one is 6. So my solutions for this are -3 and -6. And that is the end of these notes. It's crazy, right? 109 pages. I hope you had a wonderful course, and good luck on your exams and your final. And I hope to see you again. So, signing out.